Hello everyone, welcome back to my YouTube channel. I hope you all are having a good day. So today the subject I'm going to be dealing with is going to be computer networks, that is going to be bearing the subject code of 21CS 52. So let's get into the video, shall we? So, talking about the contents of the video, first we're going to have the introduction to what is bit as well as byte stuffing. Then we're actually going to get into the topic of bit stuffing, followed by the mechanism of bit stuffing. Then later we are going to be seeing what byte stuffing is, the working of byte stuffing, differences between bit as well as byte stuffing, the applications for the same, and finally we have the conclusion. So let's move on forward. Firstly, we have introduction. So, bit stuffing. Bit stuffing itself is the method of adding non-information bits into the data frame so that the message sequence can be broken down for synchronization. Next, we have the importance of bit stuffing. So, bit stuffing is very crucial for ensuring the synchronization and the unambiguous frame boundaries in data transmission. It is also going to play a very important role in preventing the misinterpretation of delimiters, promoting efficient communication and systems. By reducing the risk of error and aligning with standards, bit stuffing itself as a whole is going to contribute to the overall reliability as well as the integrity of the transmitted data. Next, we have byte stuffing. So, it is used to convert a message format of a sequence of bytes that may even contain reversed values into another byte sequence that actually does not contain any reserved values. Following which, we have the importance of byte stuffing. Byte stuffing is an essential work in data communication which is used to prevent the unambiguity in byte-oriented protocols. By inserting escape bytes before specific byte patterns, it is going to ensure the accurate framing aids in error detection and maintains the integrity of transmitted data. Byte stuffing contributes to reliable communication as well as protocol adherence in various networking applications. Moving on, we have byte stuffing or rather bit stuffing. So bit stuffing is the method of adding non-information bits into the data frame so that the message sequence can be broken down for the synchronization. Now the bit pattern that is going to be stuffed in this message to differentiate the data from the delimiter. This is also known as a bit oriented framing. Frame in a bit oriented protocol, the message is coded in the form of bit sequence in bit oriented protocol, and this data is represented as a text, audio, video, graphics, etc. in the upper layers of the hierarchy. A frame itself is going to consist of four parts which are given below. A first one is going to be a frame header, that is the frame header is going to represent the frame source and destination address, following which we have the payload field, that is the actual message that is to be delivered in this field. Trailer. Trailer bits are basically related to error correction and detection and in this field, following which we have flags, a sequence of the bits that is going to represent the frame sitting and ending. An 8-bit sequence that is 0 followed by 1, 1, 1, 1, 1, 1 and 0 is going to be used by most of your protocols such as the high level data link protocol. So the same is also represented in the following diagram wherein a flag is going to be present at both the starting as well as the ending of the given data transmission, and the payload of variable number of bits is going to be the actual data that is to be transmitted from the sender to the receiver, following which we have the mechanism for bit stuffing. Here, the flag itself is used as the delimiter in the framer of the data link layer, and this flag mainly consists of 6 or more consecutive 1 sequences. So in some cases, messages are also going to contain the same flag sequence. So in order to differentiate this message context, a single bit itself is going to be stuffed in the message. When the 0 bit is found in the message which is followed by the successive 5 ones, then the differentiating itself from the flag and an extra 0 bit is added after that particular 5 ones. When the receiver is going to receive the data frame sent from the sender for the destuffing, it removes all the zeros which are found after 5 consecutive ones in this data. This unstuffed message is transmitted to the upper layers of the hierarchy. The next slide is actually going to give you the diagrammatic view of the same. So here we can see that the sending machine is going to have the following data from the data form of the network layer, where bit stuffing is going to occur, wherein each and after 5 consecutive ones a zero is going to be added, and this particular data is going to be sent into the receiving machine, wherein this receiving machine is basically going to remove all the zeros that were found after the 5 consecutive bit of ones, and then basically de-stuff the message. So this is basically bit stuffing. Moving on to the next slide, we have byte stuffing. So in byte stuffing, a byte which is known as an escape character itself is going to be stuffed in the message so that the flag pattern present in the data can be differentiated from the flag representing the starting as well as the ending of the data. This also is known as a character oriented framing. In a character oriented framing, in character oriented protocols, codes like your ASCII codes are going to be used for coding the message from an 8-bit character. So a frame is going to consist of the following parts. So the first one is going to be the frame header. As usual, the frame header is going to represent the frame's source and destination address. Payload field is the actual message that is to be delivered in this field. Trailer is the bit of relations to the error correction and detection. Flags. The size of the flag is 1 byte. Here, one byte is going to be 8 bits and the flag is added to the start as well as the end of the data frame. It is a special character that is dependent on the signals of the start and the end of the frame. So the same is going to be represented in the particular diagram, wherein you are going to have a header, a trailer, a flag as well at both the positions, that is at the starting as well as at the ending. Whereas the middle position in the diagram is going to represent the payload of variable length, that is the actual data that is to be transmitted from the sender to the receiver. Moving on, we have the mechanism for byte stuffing. Here, if the message itself is going to contain a byte that is similar to the flag byte, then there is going to be a requirement of this method so that the receiver recognizes that this is not the end of the frame. The byte stuffing mechanism is used in the character oriented approach. In this byte stuffing mechanism, a special byte which is known as an escape character that is represented by ESC is used for stuffing before every byte in the message, which is similar to the flag byte. And if this message is going to contain a sequence that is actually similar to the escape character sequence, then another set of escape character sequences are going to be added, wherein that is going to be stuffed before that byte of the data. When the receiver is actually receiving this data frame sent by the sender, then for destuffing the message, it is going to remove all the bytes that are found before the escape character pattern in the data and then destuff it by removing the escape character bytes that are found before the flag pattern in the data. Then this unstuffed message is transmitted to the upper layers for further transmission of data. Moving on to the next slide, we actually have the diagram for byte stuffing, wherein this particular diagram is going to represent how the data is going to be transmitted. So here the data from the network layer is going to have a flag as well as an escape sequence. This is going to be in the sender machine's portion. Further, we have a flag at both the end, a flag, a header, followed by furthermore insertion of escape sequences because the data is going to be the same. Now again, this particular data is going to be sent to the receiving machine where this is going to be destuffed or rather unstuffed for the actual data to be received. Moving on to the next slide, we have the applications. So first of all, we have applications of byte stuffing. High level data link control, that is HDLC. The purpose is to ensure proper synchronization and framing in data transmission. How? Bit stuffing is applied to prevent misinterpretation of control information as a frame boundaries. Asynchronous transfer mode, that is ATM. Purpose here is facilitating the efficient and accurate data transfer in higher speed networks. This is done how? Bit stuffing helps in maintaining synchronization and delimitate the frame boundaries in ATM cells. Next one, we have point-to-point protocol, that is PPP. Purpose: presents ambiguity with frame delimiters in point-to-point communication. How? By bit stuffing is going to be used to ensure clear framing and accurate interpretation of transmitted data. Next one is Bluetooth communication. Purpose: supports reliable wireless communication between devices. How? By bit stuffing aids in synchronization and framing, contributing to error-free Bluetooth data transmission. Next, we have the NFS, that is the network file system. Purpose: enables seamless sharing of files across a network. How? By bit stuffing ensuring precise framing, protocoling accurate file transfer and data integrity. W LAN, that is wireless LAN or Wi-Fi protocol. Purpose here is facilitating reliable wireless data transmission. How again byte stuffing is employed to maintain synchronization and prevent misalignment in the Wi-Fi frames. Moving on to the next slide, we have applications of byte stuffing. First one is going to be universal plug and play, that is UPnP. Purpose is going to be facilitating seamless discovery and communication between network devices. How? By byte stuffing may be even used to prevent conflicts in data that can be misinterpreted as control information. Next, we have data storage protocols. Purpose is ensuring proper storage and retrieval. Byte stuffing can also be applied to avoid conflicts with reserved byte patterns in data storage scenarios. FTP is file transfer protocol. Purpose is supporting reliable and secure transfers of files between the systems. Byte stuffing is also going to help in maintaining framing integrity during the transmission of file and data. Network printing protocols. Purpose here is facilitating communication between computers and printers. This is going to be done to ensure accurate framing, preventing misinterpretation of data during print jobs. And lastly, we have RPC protocols, that is the remote procedure call protocols. Purpose here is to support communication between process on different systems. Byte stuffing may also be employed to avoid conflicts and ensure proper framing of RPC messages. Moving on to the next slide, we have the conclusion. Here, in conclusion, both that is bit as well as byte stuffing are indispensable techniques in data communication, ensuring the integrity, synchronization, and reliable transmission of information. Bit stuffing, with its granular approach at the bit level, is widely used in order to prevent misinterpretation of control information in various protocols like HDLC. On the other hand, we have byte stuffing that is going to extend the concept to byte level granularity, finding applications in protocols like PPP and scenarios where byte-oriented framing is essential. These techniques play a pivotal role in preventing unambiguity, supporting error detection, and maintaining adherence to communication standards. So, the careful implementation of bit as well as byte stuffing is fundamental to the seamless operation of diverse networking applications, ensuring the efficient and secure exchange of data. So, I hope that you understood what bit as well as byte stuffing was in this video, how the actual mechanism works, as well as the advantages, disadvantages, and the applications of both bit as well as byte stuffing. I hope you enjoyed the video and thank you for watching.